Hey everybody, welcome back to the channel. What we're going to talk about now is a way to group terms, numbers, etc. in what we call a matrix. Okay, so this is not the movie matrix, this is the mathematical matrix. And these right here are two different examples of matrices. Okay, so the way we define a matrix is we call it by its row by column. So that's how we figure out what type of matrix it is, okay? So the simple way that you can remember row by column is, and this is what always makes sense to most of my students, columns are our vertical sets. Think about the Parthenon. You guys are thinking about ancient Greece, okay? The Parthenon columns are vertical, okay? Just a little way to remember it. So then the rows are your horizontal, terms in here. So if I'm looking as to what to call this right now, how many rows do I have? This one up here is a 2. And then how many columns do I have? It is a 2 by 3. So it's a 2 by 3 matrix, okay? Same thing at this example right here. How many rows do we have? We have 4 rows by 1 column. Now, when we work with matrices, we have to make sure when we add or subtract them, they are identical matrices. So if I have a 2 by 3 here, I can only add or subtract with another 2 by 3 matrix, okay? If that's not the case, then we would have a solution that we would call undefined in that moment, okay? Because we can't actually combine with stuff that we don't know, okay? So luckily here, you are going to be focusing just on matrices that are identical, okay? So notice we have a 2 by 3, we have another 2 by 3, we have a 4 by 1, we have a 4 by 1, okay? So all we're going to really do here is group these terms, okay? So I'm going to create my other 2 by 3 matrix over here, okay? And then each term corresponds to the like term in its corresponding place in the other matrix, okay? So I have essentially here 6 different mathematical problems to take care of. I look in my top left corner, I have -2 here, okay? So the first problem I'm computing is -2, my sign is addition, all of these will be through addition, okay? And then the corresponding piece, the piece that's in the same spot in the other matrix is again another -2. So my first question that I'm answering is what's -2 plus -2, which we all should know by now is -4. And notice I place it identically in a corresponding space in this matrix as well, my final solution. So -2 plus -2. Then my next one, I'm just going to go and finish the row. I have a 2 corresponding to that 2 in the middle here is a 6. So what do I have here? I have a 2 plus 6, which therefore is an 8. And then lastly, in this one, I have a 3 plus -3. And we know that 3 plus -3, it's a lot like saying 3 minus 3 ends up being 0. So I grouped that top row. Now I'm going to finish the bottom row. So the bottom row, I come down here. We start with this -2. -2 plus 2. We know that -2 plus 2 is going to be 0. My next one, 5 plus -1 becomes 4. And my last one, -4 plus -5, we know is -9. And that will be as far as you could go. So you end, if you started with a 2 by 3, you added a 2 by 3, you're going to end with a 2 by 3. And that's it. Okay? Second one down here, very simple. This one you actually only have 4 problems to work on. And by the way, if this strategy works by you guys, if you want to color code it, or if you want to box off the same terms you're adding or subtracting together, by all means do it, okay? So these are pretty simple. You just go straight across, and this time it's just through subtraction. So again, I have a 4 by 1 in my solution. I'm going to put it right here. 5 minus -1. If you have to write that out, make sure you change your sign to make that addition. Make it 5 plus 1, which is 6. Please do so. -1 minus -5. Whoops. Again, addition, so that actually becomes +4. Okay? 6 minus -2. We know again, we have addition here, becomes 8, and then -6 minus -3. So if you see here with subtraction, a lot of times you're going to be thinking about, do I have to change these into addition? Okay? Ends up being -3, and you are finished.